average rate of change of a function between 2 points. So the function that I would like to use is y equals to f of x. So whenever people write a function, they tend to use f of x. F is the name of the function, x is the independent variable. You can use y equals to, so they are pretty much the same, y equals to or f of x. We have 2 points. The first point I would like to call that x equals to a. The second point is x equals to b. So to me, the best way to explain average rate of change, I would just use a simple case scenario. So let's say you drive to a road trip and then you spend 3 hours on the road. Okay, so what I am going to do is I'm trying to study your driving behavior, your speed, because some people drive safely, some people drive aggressively, right? So you drove for 3 hours, right? So let's say we just cut 1 hour, okay? Just cut 1 hour within this 3 hour time window. And then I would like to use a function. So there are 3 ways to describe your driving behavior or the speed of your car. So the first way is you use a function, right? I can use f of x equals to whatever. So that is one function to describe your behavior. One function, one line to describe your driving behavior, the speed of your car, whatever you like to call. Just one function, f of x equals to, you can use f of x equals to x squared plus 1. Whatever that is one function to describe your overall behavior. One function, okay, to describe your behavior. Another way to do this is I graph the function. I sketch the graph of the function just like that. I'm not saying this is y equals to x plus 1, just a random curve. So what I'm trying to do is I'm trying to use this curve to describe your driving behavior. So this is what f of x equals to. This is your 1 hour time window. So instead of using an x-axis, you can just call this your time from x equals to 0 to x equals to 60. So let's say you just divide the 1 hour into 60 minutes. All right, and then the y, instead of using y, you can use miles per hour. So if you treat this as the speed of your car, so you initially you are at time equals to 1, you are driving that fast, and then you are slowing down, right? Because as time increases, you are driving slower and slower, so your mph is decreasing, and then you reach to the bottom, and then starting at this time you go back up, you slow down, you keep slowing down, and then now you speed up. So that is how you check out the graph. Okay, and then another way to describe your driving behavior is using a table value. So I don't even need to put numbers in there because the formula is not that complicated. We can just use x1 and y1. So at this time you are driving that fast, at this time you are driving that fast, so on and so forth. So let's say I want to find the average rate of change. So ROC means rate of change between x2 y2 and x5 y5. I want to find your average rate of change between these two, between x2 and x5. So within this time period, what is your average rate of change? This is easy. Just like finding the slope of a straight line, we use y5 minus y2 over x5 minus x2, or you can say f of x5 minus f of x2 divided by x5 minus x2. So that is just like finding the slope of a straight line. Remember that slope of a straight line, you have 2 points on a graph, you use y2 minus y1 over x2 minus x1. This is completely the same. Then the next question that you need to ask me is, hey, you just say that is the formula of finding the slope of a straight line. You said straight line, but this is a curve. This is not a straight line. So can you still use the straight line formula? I am not saying that I am looking for the slope of this curve. I just want to get a rough average. So from this point to this point, look at the purple line. For this correspond to x1, let's say that corresponds to x2. I know this is a curve, this is not a straight line. The average rate of change is just to look for a rough average. I just want to estimate the slope, a rough average. I am not looking for the exact slope, I am looking for an average. Again, just an average. From this point to this point, I know the curve is going downhill, the slope is negative. This secant line, so by the way, what is a secant line? A secant line is a line that goes through the curve twice, 2 points. Intersect the curve at 2 points. First point, second point. And then I build a secant line. So the y5 minus y2 over x5 minus x2 is the slope of this secant line, which is equals to the average rate of change between these 2 points. The average rate of change between these 2 points is equal to the slope of the secant line, which is y5 minus y2 over x5 minus x2. You can call this y2 minus y1 over x2 minus x1. On top, you use the second y minus the first y. On the bottom, you use the second x minus the first x. So that gives you the slope of this secant line, which is equal to the average rate of change of this curve between this point and this point. And then here is another example. I know this is a curve. I just want to get a rough average. So this is my x1, this is my y1. To estimate the slope of this curve between these 2 points, I use y2 minus y1 divided by x2 minus x1. y2 minus y1 over x2 minus x1. That the result, whatever fractions or integers or decimals you get, that is the slope of this secant line. The slope of this secant line is equal to the average rate of change of the function f of x between these 2 points, this little curve. I'm using the slope of this straight line to estimate, to give a rough estimate of the slope of this curve. Okay, so the formula once again, average rate of change. Sometimes we use ROC for rate of change. That is equal to the change of y over change of x. This is not a triangle. This is actually a Greek letter that is called delta. Delta y over delta x, which is f of b minus f of a over b minus a, which is equal to the slope of a secant line. Once again, I am using this piece one more time. I have a curve. I am not saying that the slope of the secant line is exactly the same as the slope of the curve. No, I'm not trying to say that. I'm trying to say I would like to use the slope of this secant line to estimate the slope of this curve between these 2 points. Okay, so f of b minus f of a over b minus a, just like y2 minus y1 over x2 minus x1, the slope of a straight line. Okay, let's do a quick example. The reason I gave you a graph, a function, and a table value is depending on the problem. Sometimes they give you a table, sometimes they give you a graph, sometimes they give you a function. And then before I get into the first example, the numerator f of b minus f of a is called the net change. They don't use in your future classes, you don't see this word all the time, but it is good to know. Okay, I have a function for you, f of x equals to x squared minus 3x, and then I want to do 3 exercise, x1, x2, I gave you 3 pairs of that. Let's get started. So the first pair, let's pick a different color to do this. So we have f of x equals to x squared minus 3x, and then x1, right? So we have f of negative 1, that is a negative 1 squared minus 3 times negative 1, so which is 1 plus 3 equals to 4. And then you plug in the other one, f of 3. F of 3, this is a 3 squared minus 3 times 3. So this is a 9 minus 9 equals to 0. Let me make sure I got this right. Negative 1 squared. Yep. So what is the net change? The net change is, okay, let's do the rate of change first. So the average rate of change, so that is equals to f of 3 minus f of negative 1 divided by 3 minus negative 1, right? And then the net change, you have a 0 minus 4 divided by 3 plus 1 is equals to 4. So negative 4 over 4, the average rate of change is negative 1. So what does that mean? If you sketch the graph of this, x squared minus 3x, you can do this on your decimal. The slope between negative 1 and 3 is is approximately negative 1. The slope of the piece, a little piece of curve between x equals to negative 1 and x equals to 3 is approximately negative 1. So that means the curve must be going downhill. All right, how about the next one? Okay, before we move on, so this is the 0 minus 4. So this is what is this? This is a net change, the numerator. All right, so let's do the next piece. The next piece we have f of negative 2. Okay, we should not use highlighter. Okay, so we have f of negative 2, that is negative 2 square minus 3 times negative 2, that is 4 plus 6 equals to 10. F of 0, so 0 square minus 3 times 0, this is equals to 0. So the average rate of change, we have f of negative 2 minus, oh no, f of 0. F of 0 minus f of negative 2 divided by 0 minus negative 2. F of 0 is 0 minus 10 divided by 2. So we have negative 10 divided by 2, that is equals to negative 5. That is the slope of a secant line. So slope of secant line. And then this is also the average rate of change. Okay, so that means if you graph this, x squared minus 3x, the average slope between x equals to negative 2 to 0. So you just look at that piece. From negative 2 to 0, the slope is approximately negative 5. If you draw a straight line to connect these 2 points, when x is equals to negative 2, y is equals to 10. When x is equals to 0, y is equals to 0, you have 2 points on the graph. You connect them using a straight line. The slope of the straight line is negative 5. Okay, the last example, sometimes instead of giving you a number, they will just give you a 4 plus h. But that doesn't make the problem change much. Okay, before we get into the next step, this 0 minus negative 10, what is this called? This is called the net change. Right, net change. Okay, the last part, so let's do f of 4 plus h. Okay, so that is 4 plus h squared minus 3 times 4 plus h. Okay, I think the problem wants me to fully expand that. So you have, remember this, 4 plus h times 4 plus h. 4 times 4. 4 times h times 4. h times h. So you have 16 plus 8h plus h squared. All right, so you have 16 plus 8h plus h squared. Negative 3 times 4, negative 3 times h. So you have 16 minus 12, 4. 8 minus 3, 5. And then h squared. So that is your 4 plus h. And then f of 1, you just plug in 1. So that is a 1 squared minus 3 times 1. 1 minus 3 is negative 2. And then the average rate of change is f of 4 plus h minus f of 1 divided by x2 minus x1, which is 4 plus h minus 1. So this will be, the top will be a 4 plus 5h plus h squared minus negative 2. And then the bottom, 4 minus 1 is 3, so this will be 3 plus h. And then you have a 4 plus 2 is 6, so you have your h squared plus 5h, and then plus 6 divided by 3 plus h. Does the factor help? I don't think so. So if you factor the top, I don't think that is going to help. I don't think that is going to reduce the denominator. Does that? So x6, 5, 2, and 3. Okay, maybe that helps. So you have h plus 2, and then h plus 3. Okay, 3 plus h. and then you get rid of that. So the average rate of change is h plus 2. So this is the average rate of change between those 2 points. Between those 2 points. Or you have 2 points on the graph, right? When x is equals to this, y is equals to this. When x is equals to -1, y is equals to -2. You have 2 points on the graph. Sketch a straight line, connect these 2 points. The slope between these 2 points is h plus 2. That is also the average rate of change of the given function, which is right here, the green line between those 2 points. All right, so that is the end of this video. If you like the way I explain average rate of change, give this video a thumbs up. If this is something you'd like to see, subscribe, stay tuned, and I will meet you all in the next video. Signing out.